1.3, part 2, Math 9. And what we're talking about now, we talked about 2D, areas of 2D shapes yesterday with this worksheet I gave you. Looked something like this. We worked on areas of squares, of rectangles, of triangles here, of circles, and of trapezoids. So trapezoid was maybe the one that you were least familiar with there. So this sheet should be complete as well as the other ones. But today we focus on 3D shapes. Am I still frozen? All right, here we go. Today we focus on 3D shapes. So obviously 2D shapes are just a flat, circle or square. 3D shapes would be 3 dimensions, right? So you have length, you have width, and now you have depth, or you have length and width and height, right? You have 3 dimensions, so that's why it's called 3D space. We operate in 3D space. We can go left, right, we can go forward, back, we can go up, down, okay? And any movement that we move in space is a combination of sections of those 3 vectors is what they're called. But if I move this eraser straight up like this, you could say you've moved in 1 dimension. Okay? Just in 1 dimension there. If I move it this way on an angle, I've moved in this dimension and this dimension. If I move it towards you and up, I've moved in this dimension, and this dimension. There's no more dimensions in space. Okay? You can maybe think of time as a dimension, so a 4th dimension we operate in time as well. But as far as objects moving in space, 3 dimensions, length, width, height. So 3-dimensional figures, how do we find the surface area of 3-dimensional figures? Well, have you ever drawn a diagram called a net diagram before? Have you done that in school before? Okay. Now, some of you may like those, some of you may not. I'm going to do net diagrams with you, so to make sure that you understand those, because for most of you, that will help you visualize. It'll help you visualize all of the surfaces, and you'll be able to see them all, because in a picture like this, you can't see all the faces of the figure. Okay, so the net diagram looks like this. I want to draw this front face, which is going to be really easy to do. I'm going to draw just like this. It doesn't have to be the exact same size. I'm going to draw the front face like this. Okay, that's the front face. You see that? Now the top face would be connected to the front face. So I'm going to draw that connected up here like this. Now we don't know exactly the dimensions, so we don't know if it's bigger or smaller or what, but I'll draw it roughly the same size. But this is the top face, and so basically it's like a cardboard box that we are splitting at the seams, at some of the seams, and we're flattening it out and placing it on the ground. That's what we're doing. And so here's the front and the top. Now the bottom you can't see, but when we're asked to find the surface area of a 3D figure, we have to account for all of the sides, even if we don't see them. And so the bottom, let's say the bottom, and I'm gonna draw this like this right here. So the bottom is going to be this blue rectangle. Okay? Yeah, you can knock off some lights, just not all of them. So the blue rectangle would be attached again to the front face, but on this side. So here is the bottom. See, blue for bottom. Okay? So you see those front 3, right? We've got the front face, we've got the top and the bottom. Everyone see that? We've got those split and pasted on the board there. Now the side is looks like a bit of a square actually. So it's a little bit smaller. It's shorter than the front side looks like. So I'm going to draw it on the side. So this is the edge right here. This edge right here is right here. So they're connected, front and side. What color should I do that? I'll do yellow. Yellow might not be easy for you to see on the board there. Oh yeah, not too bad. So that's the one side. Okay, I'm going to do the other side. That's the same. I'm going to do that in yellow as well, and I'm going to attach that over here. So hopefully this is ringing a bell that you remember how to do net diagrams. Can everybody give me a nod, or if you've seen this before? Okay. Now, have I got them all? No. What am I missing? Well, I'm missing, okay, I've got the top technically. I'm missing the back side, let's say. That back side of the rectangle. So I'm going to, let's see, I don't know, well, let's get some other colors here. Green. Oh yeah. So here's the back side. Okay, it's the back vertical side. Little tough to tell once I have all those marks on the same spot. But I'm going to attach it to here. Now you can attach it to the top, or you can attach it to the blue bottom side. It's attached to both the red top and to the blue bottom. You see that? So you can pile it up there wherever you want. And in green, so here's the back side. You see that? Okay. So this is called a net diagram. A net diagram. And you want to think about a cardboard box, literally, that we've cut at some of the seams or sliced with a utility knife at some of the seams, and we're able to flatten it all out, spread it all out, and lay it on the ground. So this is what a cardboard box might look like if you keep all of the sides attached to at least one other side. Okay? All right. So why is this helpful? Well, because now it's going to be probably a little bit easier. If I take away all that, look at that. It's a little bit easier to identify all the different sides. So here we have this front side, the bottom, the top, the two sides, and the back side. Okay? So this is called a net diagram. And you'll have to draw some net diagrams. You'll have to work with net diagrams here. And like I say, some of you may find this extremely helpful. Some of you may not find it as helpful if you can visualize things in your head a little bit better. If that's something that's easy for you to visualize and to move shapes around in your mind as you envision them. If you can keep track of like this is called a rectangular prism. And if you can keep track of 6 sides in your head, you can see 3 of them usually. 1, 2, 3. If you can keep track of the other sides, you know, net diagrams, as you move on in math, you won't have to draw net diagrams all the time. But in Math 9 here, I'd like you to draw net diagrams and get a little bit comfortable with them, because some of you are really going to rely on them, okay? All right, so here's an example. Here's an example of a prism that has, now we have some markings on them. Okay, and so what we're going to be able to do is we're going to be able to find the surface area. And if you don't have your notes today, just copy this out. This will be really the last example before we move to the handout worksheets that you're going to work on today. The worksheets as well, if you don't have the worksheets, they are on my website, so you can go there to print out a new copy of the worksheets if you've lost them. So here they are right here, it's mrmathwell.com, and here's the worksheet right here. So this is what we will be working with today. We did the first 4 pages yesterday, and we are going to be looking at this here today, okay? So let's get on with this. Now, I hope you remember what these little marks mean. I talked about this yesterday. I see that I have, well, let's start with number 1. So I have 1 tick mark right here. Do you see that? I also have 1 tick mark right here and another single tick mark right here. What do those single tick marks indicate? Do you remember from yesterday? Yeah.
That the sides are equal.
Okay, all the sides with the same tick mark are equal in length. Perfect. So what is the length of all of these sides that have a single tick mark? 2. Very good. Why? Because look at this. You've seen a 2 attached with this side. So all of the other single tick marks, this is 2 as well. This is 2 centimeters. Okay? Excellent. And the same holds true for the 2 ticks. Okay? So this side and this side are the same as well as this side. Okay. And this appears to be 4. It's a little off center there, but those are 4 centimeters. So this looks like a square, but it's not a square, is it? It's pretty thin on top and it's twice as long. So it's actually a little bit more like this if you envision it. It's a rectangle. Okay? And the diagrams that you see in your textbook or in your notes packages do not have to be to scale. So that's why these markings are really important, that you understand what they mean. Because you might look at that and say, oh, it's a square, 2 by 2, or 4 by 4. Wait, what? It's not a square. And if you look carefully, it maybe looks like it's taller than it is wide, but with the 3-dimensional view, it is a little tough to tell. Okay, what length is this side right here? From here to here, what is it? 10. Very good, you got it. 10 centimeters. So is this one and this one. Okay, excellent. Let's draw a net diagram. Let's draw a net diagram, and we're going to label the lengths of many of the sides, okay? So let's do the front face. I always like to start with the front face. We'll put that kind of right in the middle of the area that we have to work with here. So here's the front face in the middle. Now, just inside this rectangle, I'm going to label some dimensions. So what's the top side of this front face again? That's 10. Good. You don't have to write the units because it's just going to get really busy with the units there. We'll understand that they're all centimeters. That's excellent. We'll make sure we include that in our final answer when we're all done, okay? And literally, the surface area of this prism of a 3-dimensional shape is just adding, I don't know if I mentioned this even yet, but we add up all of the areas of all the sides. That's all we do. Find the area of each of the 6 sides and add them up. And that's the total surface area, right? The surface area would be the area of the outside areas that are exposed to the air, okay? Or that are exposed to outside space. So it's not the inside capacity, it's not volume, it's not how much liquid you could put inside a shape like this, that's volume. But surface area would be kind of how much of this shape is exposed to the air. Or if you had to paint this rectangular prism right here, if you had to paint it, how much paint would you need? It's the area of all the sides if you want to cover all the sides. Okay? Just because I don't know if I've explicitly explained that. All right, what is this length right here on the right? This is 4. Very good. Okay, so that's the front side gone. Let's do the top. And it's going to be, how tall should I make the top? Should I make it the same height as this? No, this height is only 2. So I'm going to try and draw this to scale a little bit. I'm going to make it half as high. See, that's what the top might look like. This is going to be 2 here. And what's the length? 10 again. Very good. Okay. All right. Let's do the bottom. So the bottom is attached to the front here, and it's going to be, well, it's going to be 2 in length here, or width here, and then 10 as well. So it's going to be the same as the top, isn't it? Okay, so we got 3 pieces of the net. Let's do the sides now. So they're going to be obviously 4 because they're attached here at this edge. 4 by 2. Very good. So we'll just go out 2. So it looks pretty much the same as the top and bottom. All right, this is 4 and that's 2. Same on the other side. And you don't have to use a ruler for this. You can use a ruler. I appreciate nice straight 90-degree corners. But please don't take a whole ton of time with the ruler doing this. Like if you have to take 10 minutes to draw a beautiful net, that's too long. So just try and get very careful with your freehand sketching. And if it looks like mine, which is not perfect, it's still okay. All right? So that's going to be 2 as well by 4. Okay. Am I done? No, what am I missing? Oh, the back side. Right, right. So what is the back side? The back side is 4 by 10. So I'm going to attach it to the top like I did with the other one. And I have to go 4 units here by 10. So it's the same as the front side, isn't it? So as long as that's pretty close. And I only need... it's pretty close. It's not quite the same as the front side, I guess, but it should be it. Actually, that does bug me a little bit. Let me fix that. So it's going to be 4 is going to be about that long. Okay. Make it a little bit closer to the front side. There we go. There we go. And of course that's 10. Okay. Now, do you have to label absolutely every edge like I have? No, I didn't label every edge. But what I did was I tried to do this. I tried to show you that we're going to be able to calculate the area of each of these 6 faces, and I'm going to highlight the numbers that we're going to use to do that. So we started with the front face, okay? And let's call this front face area 1. You see that? Area 1, that's the front face. That's going to be A1. A2, let's make the other ones. So let's make the top A2, the bottom A3, the sides in that order, A4, A5. Now, why am I calling them A's? Because I'm looking for area. Very good. And A6. So I need 6 sides to a rectangular prism. Always 6 sides. 6 sides always. Different prisms will have different numbers of sides. Like triangular prisms will have different number of sides. But rectangular prisms have 6. Think of a cardboard box, right? So let's do this. So how we're going to do this is we're going to do A1. Area 1 is going to be 10 times 4. Length times width. Everyone see that? 10 times 4. And we are going to do these individually. So I want you to write this out exactly like I'm doing it so that you have in your notes a model of exactly how it should be done 100%. Okay? And that is 40 what? Centimeters squared. Good. All right, centimeters squared. So that's area 1. Okay? Now, we have some other areas that are going to be the same, and we're going to write them all out separately now, okay, for this example. So A2, Let's see which one's the same. Is A2 going to be the same? No, it's not going to be the same. It's 10 times 2. So let's go 10 times 2 equals 20 centimeters squared. Writing this down? Writing this down? You got it? Okay, you're writing everything I'm writing down there? All right, make sure you show all your work. Thank you. Okay, A2's done. Good. A1's done. A2's done. What about A3? Excellent. A3 is going to be the exact same as A2. 10 times 2. That's 20 centimeters squared. A4. Let's see. Okay, here's where I'll let you take some shortcuts. Now watch this. I said I was going to make you do it all, but watch this. A4, we know for a fact, is the same as what? A5. So you can start doing this now. A4 equals A5, right? Which equals what? 2 times 4 is 8 centimeters squared. So please make sure that you count this twice. So A4 is 8 centimeters squared. A5 is also 8 centimeters squared. So please, if you do this, you show your work once, I'm okay with that. But make sure you count this twice. Okay? And A6, we did see was the same as A1. So A1 is the same. So let's write this out. 10 times 4 is 40 centimeters squared. So I'd like you to write AT for A total area total. So the total area is AT. Okay? And again, this is the way I work with all of my math classes. So you'll see this all throughout high school. The same methods, a lot of the same notation. We do a lot of the same stuff here at this school. Between us math teachers, we talk a lot about stuff. So you'll see a lot of the very same notation. And if you happen to see me again in math classes, you'll get the exact same notation you're learning here today. So the area total is going to be area 1 plus area 2 plus area 3 plus area 4 plus area 5 plus area 6. So the area total is 40 plus 20 plus 20 plus 8 plus 8 plus 40. 1, 2, 3, 4, 5, 6. Okay. So 40 and 40 is 80, and 20 is 100, 120, 136. Did you guys get that? Yeah. Awesome. Centimeters squared, right. 136 centimeters squared. Okay, does that look reasonable to everyone? Does anyone have any questions about that? Okay. All right. So net diagrams are going to be the way we're going to work with this one. Okay. So let's do. I'm going to hand out these worksheets to you right now. I have them right here, and let's do some of these together. Okay, folks. You will need your. It's an extra piece of paper. You will not have enough room to show all your work. So let's take number 1. And you'll have to show your work on a separate piece of paper because I do want you to show your net diagrams for these for this page. Okay, net diagrams for this page. You only have to do 6, so I'll do 1 with you here for sure. But you do need to include net diagrams with this page, so you might have to attach a separate page with your work. You can put your answers here, but I'll need to see your work as well. All right. So I'll do number 1 with you. And where will I do that? I will do that on a separate page, which I will try and move into position here. Okay. There we go. It's rather large. Okay, net diagram. I'm going to go a little bit quicker here now. The front face, I like the front face. Is it a rectangle or a square? What is it? Yeah, it is a rectangle because all sides are not equal. So I'm going to put 12 there and 7 there. The top is going to have a length of 4 here and a width, or the sideways length of 12. What should the bottom have? We can assume that these are right rectangular prisms. So the top and the bottom should be equal. 4 by 12. The sides should also be equal. So this is going to be 7 by 4. on either side. 4 there, 7 there. And we've got the back side, which you can put on the top or the bottom. I'm going to put it on the bottom this time because I got more space there. Should be the same as what? The top, which is 4 by, sorry, it's 7 by 12, right? So the same as the front side. All right. Okay, does that look accurate to everyone? All right, okay, you guys agree with that? All right, so let's say I'm going to do area 1, area 2, area 3, area 4, area 5, and area 6. You can label them a little bit differently, but if you're following along with me, you want to label them the same as me, perhaps. So, all right. Area 1 is 7 times 12, which is going to be 84. Now, we'll do our units at the very end because this doesn't have to take a long time. So area 2 is 4 times 12. You see that? 4 times 12, which is 48. Area 3 is going to be 4 times 12, which is another 48. Again, I'm going a little bit faster here. If you're not understanding something, I'd love to just pause and clarify. Just let me know. But looks like you're all engaged here. So if you understand what's going on, that's great. I'll keep rocking. A4, that's the, what is that, the back side here now. 7 times 12 is 84. And then the two sides, so A5, and I'll do them all separately because I think that's probably just the best. A5 is 4 times 7, which is 28. And A6 is the same. 4 times 7 is 28. So AT equals, now you can just go ahead and add up all of the numbers. And if you want, at this point, it's no problem. You can combine the like ones. So you can go 2 times 84 plus 2 times 48 plus 2 times 28. That's a bit of a shortcut. That's pretty reasonable. Area total. And if it's smaller numbers that you want to do in your head, I would encourage you to do that mentally. If it's larger numbers, if you want to use your calculator, you just go right ahead. So I'm just going to do this in my head here. I'll show you how you might get some exercise doing that. So 2 times 84, 2 times 80 is 160. So 2 times 4 is 8, so 168. 2 times 48, that's going to be 96. And 2 times 28 is going to be 56. So 168 plus 96, that's 4 off of 100. So 268 minus 4 is 264 plus 56. 260 and 50 is 310 plus another 4 and 6 is 10, so 220. Did I get that right? Yeah. All right, 220. So area total is 220. I can stop right there, correct? 320, thank you, 320. And what else am I missing? Okay, it's actually, this one's millimeters. Yeah, this one's millimeters. All right, so millimeters, is that squared? Thank you, millimeters squared. Okay. So the area total, 320 millimeters squared. And that is a great looking question right there. If you do that, you will definitely get 100% on the test, and you can. And the thing is, I'm not too concerned. I'm not as concerned that you have the right answer. I'm concerned that you know properly how to get the right answer. So you need to communicate with me that you know what you're doing. I think that's a misconception. It's like, oh, the teachers are just making us do stuff we don't really need to do. I know how to do this. What's the point? In order for you to get full marks, you have to show me that you fully understand it, okay? Think about it that way. So you have to communicate to me that you know how to get this from scratch to the correct answer, okay, all the way through. You're not guessing, right? You're not just getting it off a friend and for your homework, whatever, right? You know how to do it. So if you want full marks, you got to show me that you know how to do it. Got it? Just think about it that way. Yeah, okay. Any questions about this one? Weird. That was a question from out in the hall. Okay. So you guys can go ahead and continue on with your worksheets, which, where did that go? Yeah, right there. Net diagram. So we did number 1. What was that? 320, we said? 320. And I've got the work on another page. There you go. You don't have to circle that, I guess. I just always circle my answers, but you can just, if it's in the spot there, that's fine. All right, so I'll give you some time to do that. If anybody has any questions, then you can let me know. I might give you a couple more answers here just so you can check to see that you're on the right track, okay? Okay, so number 3, I'm going to draw the net diagram kind of to scale. Whoops, a little bit to scale anyways. So the front face is going to look similar to the front face there. That's going to be 9 and 16. The top is going to be, of course, 9 by 11. So we'll go straight up there. That's going to be 11. Okay, the bottom side is going to also be 9 by 11. This little side here is going to be 16 by 11. Same as the other side. And then the back side, we'll stick that on somewhere. And the back side can go on the, attached to the top, the bottom, or one of the sides. So I'm actually going to, watch this. The back side here, you can draw it like, whoops, the back side here. I'm going to stick it over here on the side here because that'll work too. And that's going to be, what's going to be 9? It's going to be, whoops. Yeah, it's going to be 9 by, we already have that 16 there where it's attached to, so 9 by 16. So you can attach the back side on the top here, on the side here, on the bottom here, or over here, whichever way you want. So, area 1 is the front side, so I'll make this area 1. Area 1 is 9 times 16, which is, what's that, 90 and 54, so 144. Area 2, let's make area 2 the back side, which is going to be the same, right? Okay, area 3 and area 4 will be equal. We'll make those the top side. Area 3, 9 times 11 is, what's that? 101. Oops. 99. 101. What am I doing? A4, it's going to be the bottom side, same thing. And then A5 and 6 will be the two sides. Looks like they should be the same. 10 times 11. Which is 110 for each. So surface area total, and some people say SA for surface area. I like that too, surface area, because that's SA. In your textbooks, you'll see SA for surface area, so I love that too. You can do that as well.
Where did you get the 10 from?
Where to get the 10 from? Oh, that's a good question. What? That's a 16, isn't it? Yeah. Oh, my messy writing there. Look at that. So that's a 16. Gotta get my glasses on. You are correct. So that's going to have to change to, that's a 16. Good catch. 176 is correct. Good job. Okay, anything else there that I misread? No. All right. All right. Write neatly, kids. And get glasses if you need them. All right. Thanks for that. Okay, so 144. So that's two 144s. Plus 2 99s, plus 2 176s. And that one you can certainly use your calculator for. Would look something like this. 2 times 144 plus 2 bracket 99 bracket plus 2 bracket 176. And when you just type a bracket in your calculator like that, it automatically multiplies. So you can put times, or you can just leave it like that. It should work out. Okay. So I got 838. Did anybody else get 838 for number 3?
Yeah.
Good. And we'll make sure we put our units on there. 838 centimeters squared. It is an area, so it's squared units. Any questions about that? As we move through 1.3, I want to show you, and this is the second page of your worksheet notes, which we're going to get to. But in this worksheet here, where did it go? Oh, where was it? Okay. So in this is kind of our first look at composite objects. So 1.4 is going to be complicated composite objects with lots of different kinds of shapes. This is still rectangular prisms, but this is a step up now. So now it almost looks like we've got two rectangular prisms stuck together. Do you guys see that? Okay. So in this worksheet, because some of you are done the first worksheet. Oh, where'd my pen go? Here it is. I want to take a look at this one. So question number 1. All right. Whoopsie. Let's go back to answer page. Okay. Go back to 100%. So it's basically like we're taking 2 of these and sticking them together now. And there's going to be more than 6 sides is what this means. Okay? There's going to be more than 6 sides. A net diagram might still be a good idea. Net diagrams are going to get a little bit more complicated to do here. So I would, for this one, I would do something more like this. I would label each side that you can see as area 1, area 2, area 3, area 4. And then I would, for the ones that you can't see, the back sides and the bottom that you can't see, you're going to want to pair those with a side that if there's a side that's equal to, okay? So for example, let's do area 1 here, and then let's do area 2 up here, area 3 here, area 4 here, and area 5. So on your worksheet, even if you're not there, flip it to the back side and work on this first problem with me, okay? And we're going to take a little bit of time. We're going to take the last 10-15 minutes of class here and work through this so that you guys can start to do that second half of your worksheet assignment. All right. So now I understand that there are, and I'm going to try and draw this, you don't have to draw this, but in the back side, there's going to be a side that's exactly the same as A1. You see that? And back here, there's going to be a side that's exactly the same as, well, that's actually going to be the same as A3 plus A5. Okay? That one's going to be a little bit harder to see. But the bottom side, let's see the bottom side here, looks like this, and it's going to be the same as A2 and A4. All right? So I'm actually going to show you how I would do this, or how you could look at this with Cubolinks. So give me a second. All right, take a look at this. So this is the Cubolink that I have. That's not really to scale, but it looks kind of like that one up there. You see that? Like this. Does it look like that? Let's see. So it looks like that. So we've got a top side, A2. We've got a front side, A3. We've got the top of if this is like a bench, the top of the bench is A4, and then the front of the bench here is A5. The side is A1 here. You see that? The side. So it's like a bench seat in a vehicle, maybe, let's say. Now on the back side that you can't see, I have another A1. You see? Another A1. And on the bottom, check this out. The bottom looks like this. Okay? The bottom looks like that. And that is exactly the same as what the top looks like. That is A2 plus A4. Do you see that? Okay, so again, if you move this around, the bottom side right here looks exactly the same as the top side from the top view, which is A2 and A4. So Cubolinks can sometimes come in handy here. And if you would like to use some Cubolinks for doing this assignment, and you'll be doing some of this tomorrow, okay? You'll be doing some of this tomorrow as well. But Cubolinks might be able to help you. Okay, let's get on with solving this here. So A1, I can figure out what A1 is. Well, actually, A1 is going to be a little bit of the trickier type because this is not a rectangle or a triangle or a circle or a square. This is actually a combination of 2 things, isn't it? Look at this. So you can treat this, I'm going to draw that a little bit better, but you can treat this as two separate pieces. So what is this piece right here? That is 11 by 3. So area 1 is 11 times 3 plus, what's this one? 4 by 4. Yeah, 4 by 4. Okay, so area 1 is 16. Awesome. Let's say that the backside one is area 6. So area 6 is going to be the same as area 1. Okay, so area 1 and area 6, let's say that's the backside here. They're going to be the same. That's going to be 16. Any questions about that?
Isn't it supposed to be 33?
I'm sorry, 16 plus 33. You can't see that. It's over here, sorry. 16 plus 33. So what's 16 plus 30? That's 49. So A1 is equal to A6 is 49. Thank you. I'll write that properly. All right, let's work on A2 now. A2 is, this should be pretty easy, 3 times 12, right? That's 36. A3 is going to be, now I know what this is, that's 12. Can I figure out what this side is? Is it given? This side is not given, but can I figure this length out? Ah, so the overall height of this is 11. So think about it as a bench. The back side of the bench, the overall height is 11. And we're actually given this part right here is 4. Same as this, the same as this. So if this is 4 and this is 11, what's the difference between 4 and 11? And that's going to be this side. Okay? So this length is 11, and this length also has to be 11. Very good. Okay, you guys are on the ball. Times 7. So A3 is 12 times 7, which is what? 84? Okay. A4. Well, I've got 4 as this side. What's this one again?
12.
Same as this, and 12. Very good. 4 times 12. We're getting close. Area 5 is going to be 4 times 12 again. All right, so here's the tricky part now. What sides am I missing? I'm missing a back side, looks like. So the back side would look something like this, right?
Yeah.
Okay, so what's that going to be? That's going to be 11 by 12. Let's make that area 7, because I got 6 up here. So 11 times 12 is 132. Good. And one more, the bottom side. Now this is going to take some real work for you guys to visualize this, right? But what is that bottom side? This length is, yeah, look at 3 plus 4. Let me make. Okay, so here's 3, right? That's this is 3. That means that this would be 3. That's 3, you see? And this piece is the same as this side. So that's going to be 4. So the bottom piece is going to be 12 units here by 7. Perfect. It's going to be 12 by 7. So the 8th one is going to be 12 times 7, which is 84. Whew. I think Cubalinks might come in handy for you, right? Yeah. So you can kind of keep track. So that's probably a good idea to use some Cubalinks when you're working on this. That's high level right there. That's high level. So use a pencil and eraser, and especially for the sides that you can't see or the sides that you have to split up, you can erase. Do things one at a time, and then you can erase your lines and then start over and work on another side, like the back side here, and figure that one out and so on. Okay. All right, so now the area total for this one, or surface area total, if you want to call it that, is going to be 2 49s. I see. Those are gone. Plus 36. That's gone. Plus 80, oh, two 84s. That's there and there. Plus 2 times 84. Plus 2 times 48. Plus 132. Okay, what's the sum of this here now? What'd you get? 6 what? 698. Did anybody else get 698 on your calculator?
Wait,
You got 530?
oh,
Okay. Okay, by the witness of 2 or 3 witnesses, the truth shall be established. So what do we got here? What's the number? 530? Even 530? Okay, I'll trust you. 530. And that's going to be square yards, or yards squared. All right, so for the second part of your worksheet, that's question number 1, 530 yards squared. Sorry? Somebody got 538? Okay, do I have to do it on my own calculator? All right. All right, grade 9s, make sure that you have for sure this first page done. Okay, make sure you have this page done. You should be started on this page, which I'll give you time to finish tomorrow. And we'll use some Cubalinks tomorrow. Let me check this answer. All right, so 530 is the answer for this question. So it's 530 yards squared. There is the calculator screen right there to prove that. All right. So you'll get some time to work on this. Tomorrow there is the worksheet. If you don't have your worksheet at home, you can print it off on mrmathwell.com. And yeah, this will be the second worksheet for this section.